Having covered the essentials of time value of money, let's dive into the practical application in setting feed-in tariffs. We call the FIT. What exactly FIT is? How does the country set FIT level? Here, we are going to look at this through the example of a rooftop solar system in Taiwan. So what is the feed-in tariff? It is a crucial policy tool designed to encourage the growth of renewable energy, reduce the dependency on fossil fuels, and cut the greenhouse gas emissions. Government or energy authorities establish the contract with energy provider or the public, offering a guaranteed price for electricity generated from renewable sources like solar or wind power over the fixed period. This ensures that renewable energy producers can sell electricity at a higher, stable price, unaffected by market fluctuations. The specific rates vary depending on the type of renewable energy and the capacity of the installations, reflecting the aim to steer the development of certain renewables, advanced technology, and reduce initial costs. Generally, FIT rates are set to decrease annually or remain constant, which reflect the maturing green energy technology and the lower initial cost. Remember, the setting of FIT rates significantly impact renewable energy policy and investor interest. So how feed-in tariffs are calculated? The rates are computed by ensuring the present value of net income, which is revenue from electricity sales minus operating and maintenance cost over each period equals the initial installation cost. Let's break down the cash flow for the typical rooftop solar PV system with capacity between 1 kilowatt and 20 kilowatt. The first is the initial installation cost. This is the upfront investment required to set up the solar PV system. For our example, is 55,900 NT dollars per kilowatt. The second is the annual electricity output. Each kilowatt of our PV system produces about 1,250 kilowatt hour per year. And the third component is revenue from electricity sales. The revenue is generated by multiplying the annual electricity output by the FIT rates. And the fourth component here is the annual O&M or operating and maintenance cost. And these are ongoing expenses calculated as a percentage of the initial installation cost. Here we assume 4.39%. The timeline shows each year cash flow from 1 through 20, the expected lifespan of a system, with the interest rate noted at 5.25%. So from the cash flow diagram, we can derive this equation. Initial installation cost equals the sum of the present value of a net income, where net income is defined as the annual revenue from electricity sales minus the annual operation and maintenance cost. In this slide, we break down the feed-in tariff calculation. FIT essentially allows us to calculate the profitability of renewable energy investment like solar panels by determining the present value of the net income over their operational lifetime. We use the present value formula to discount the future cash flows, which are consistent over the expected lifespan of the installation assumed in this. So the factor P over A is the present worth factor over 20 years at an interest rate in the example. By calculating the FIT rate, we aim to cover the installation cost and all the ongoing maintenance through the revenue generated by the energy produced, which ensures the investment is financially sustainable. So here, let's examine the historical trends in feed-in tariffs for various renewable energy sources in Taiwan over the last 8 years. As seen in this figure, FIT rates generally decrease over time. This trend is largely driven by the advancement in renewable energy technologies, which leads to reduced cost. So from the formula we just saw in the previous slide, we observe that a decline in initial installation costs directly impacts the FIT rates, leading to lower subsidies. And the figure here clearly illustrates how the maturation of technology contributes to decreasing FIT rates, which align with our expectation of cheaper renewable energy as time progresses. So let's wrap up our exploration of the time value of money and its practical application in green engineering. We have navigated through cash flow diagram, the principle of interest and economic equivalence, culminated in a real-world application through our case study on feed-in tariff. See you in the next unit. Bye-bye.